Good morning, everyone. Welcome to day 4 of this summer session. I'm just impressed with the number of people showing up for the session over the last 4 days. School hasn't started, it's still your summer holidays, and here you are putting in a solid 90 minutes for 4 days straight to be with us. So thank you for being here once again. My name is Ted Zeroni. I'm a learning lead or a professional learning lead with the Edmonton Regional Learning Consortia, which are all under the umbrella of the ARPTC. I'm coming from Short Park this morning. Not with me, but helped in this session in our July summer session. This August session is a repeat, and that should not say July 24th. I should say August 24th, 2023. But Jess did the July session. She helped me put the slide deck together as well. So she's part of our science team, as is our co-host, Angela Deering. You've all met her yesterday with that fantastic presentation on computer science. It's making it really doable for us and making us think very comfortable in working with computer science. So welcome, Angela. Thank you for being my co-host this morning. Our plan for the day is whoa, I'm not going to do our plan for the day. I should press the slide before I start talking, because sometimes I change slides and I forget what comes next. Anyway, I'd like to begin again with our land acknowledgement, and I often like using a video to kind of help us hone in a little bit and make us think about our land and where we are in a little bit different way. And this morning I'd like to play with you a short little clip. Many of you may be seen it already. It's called The Honorable Harvest, and it's narrated by Robin Kimmerer, who, as you know, is the author of Braiding Sweetgrass. So if you don't mind, I would just like to play this video to start us off. It's one that maybe you've all seen before, but it's one that every time I listen to it, I really do appreciate it and get something different out of it every time.
If I could choose just a single element of the traditional teachings that we're called to pick up, it would be the teachings of the honorable harvest, which were taught us by the plants who give us everything that we need. It's a covenant of reciprocity between humans and the living world, a very sophisticated ethical protocol. One of the first steps of the honorable harvest is to understand that the lives that we are taking are the lives of generous beings, of sovereign beings. And in order to accept their gift, we owe them at least our attention. To care for them, we must know what they need. And at the very minimum, we should know their names. And yet, the average American can name over 100 corporate logos and 10 plants. Is it a surprise that we have accepted a political system that grants personhood to corporations and no status at all for wild rice and redwoods? The protocols for the honorable harvest are not really written down, but if they were, it would look something like this. When you get to the woods, you don't just start grabbing everything in sight. We're taught never to take the first plant that you see, and that means you'll never take the last. This is a prescription with inherent conservation value. And then if we encounter another plant, we ask permission. I've always been taught to address that plant, to introduce myself and tell it what it is that I have come for. If you're going to take a life, you have to be personally accountable for it. I know there are places where if you talk to a plant, they think you are crazy, but in our way, it's just good manners. If you're going to ask, you have to listen for the answer. You can listen in different ways, pragmatically, intuitively. Look around, see whether those plants have enough to share. And if the answer is no, you go home. For we remember that they don't belong to us. And taking without permission is also known as stealing. And the Honorable Harvest counsels that we also take in such a way that does the least harm and in a way that benefits the growth of the plant. Use everything that you take. It's disrespectful of the life that's given to waste it. The next tenet of the honorable harvest is to share it with others, human and non. The earth has shared generously with us, so we have to model that behavior in return. And a culture of sharing, we know, is a culture of resilience. Plant gatherers often leave a spiritual gift behind, but it can also be a material gift. Weeding, caretaking, spreading seeds, helping those plants to flourish. We give songs, we give ceremony, we give our respect, we give fertilizer. Every breath that you take is a breath that was made for you by plants. On the water that you drink, whether you're in an urban setting, whether you're on a remote mountaintop, we still are recipients of those gifts. And if we take the time to be grateful, that brings us into that state of humility, of understanding that we are not at the top of a biological hierarchy, that in fact we are the younger brothers of creation.
And excuse me, and with that, I do read the land acknowledgement for this morning, keeping in mind that this is a time of harvest, especially starting off in the southern area of Alberta, probably a little bit earlier in other places. And again, just as I opened up our first day with the video about as read the land acknowledgement, remembering not only about our relationship with the land, as this video emphasizes, but our relationship with others. So it is in the spirit of reconciliation that we want to acknowledge that this gathering is taking place on traditional lands across the province of Alberta, home to many diverse First Nations, Métis, and Inuit peoples. We acknowledge that this land is a traditional meeting ground, giving voice to its original peoples and the story of creation of this country in a way that history has forgotten. So, today's final wrap-up day is that putting it all together. We're going to be beginning by taking a look at that phases of learning for that transfer, just to review, because that really becomes the foundation of this presentation and the other presentations that Chris Sarsky and I do on the individual organizing ideas that I'll refer to again later. So with that in mind, we'll take a look at examples of how we can plan at the surface level of that phase of learning, how we can plan for the deep level, and then planning for transfer. I do have some planning templates to share with you, and we'll talk briefly about assessment, and then share some links that have some other resources which you will be which you'll have available to you. I will be pasting the link in with the slide deck a little later on in this presentation, so you'll have that. And this video will be posted a little later, or sent to you at least for sure, and I think posted in the ARPD site a little bit later. So you'll have the video and the slide deck link coming up soon. Just as a review, remember once going back to Monday, I provided a quick curriculum overview, talking about how the cusps all work together and how those individual concepts worked together to create the understandings, and that ought to be the focus. And with that in mind, then looked at briefly at the phases of learning that our curriculum, when we look at it carefully, can take us through that surface, that deep, and that transfer component of learning. In day two, Nicole Amru led us through the scientific methods and focused on the skills and procedures in an investigation, working from grade one, where we find that we do things like ask questions, make predictions, and make some observations and some conclusions. And that scientific investigation, as we move from grade two and up, was a little bit more in depth in terms of the steps of investigation, but at the end of the day, it was all there to create knowledge and develop conclusions. And yesterday, I remember a reminder that Angela was with us presenting the information on the computer science organizing idea, on how, as the grades progress, we move from focusing on instructions and following instructions and connecting that to the notion of algorithms, which is a part of that computational thinking component that we end up with in grade three. So I have the enviable task of putting it all together. As you can see, I've highlighted computer and science because you got a really in-depth look at both of those organizing ideas the other day, but it's impossible in 90 minutes to take an in-depth look at the remainder of the organizing ideas. So what I'm going to do today is just focus on one of them, and hopefully that'll add an example of how to progress through the other organizing ideas. And just a reminder, there will be some support videos for all of the organizing ideas as the year goes on, and I'll make reference to those in a little bit. But I know that sometimes what people think about is how do we really organize this together? At the end of the day, I've highlighted computer science and scientific methods simply because they're a little bit different than the others: living systems, matter, earth systems, energy, and space when you get into grades 4 and up. And once again, living systems is not part of the kindergarten curriculum or an organizing idea in kindergarten. But typically at the start of the year, because computer science and scientific methods are such process-based organizing ideas, we're finding it does make sense to take a look at those skills and processes in those organizing ideas and start the year with them, or at least working together with the first organizing idea you may choose to work with. Because as you can see, then we can take the ideas of computer science and instruction and following instructions, design thinking, and so on, and integrate those into each of those organizing ideas. Same with scientific methods. We talk about analyzing or predicting or investigating and exploring. Those are all things that we can do within each of those organizing ideas. And Angela and Nicole were giving some examples of how to do that, and there'll be more examples provided for that as the year progresses. Now, I've laid out the organizing ideas with living systems, matter, earth systems, energy, and space in that order. That is the way that Chris Zarsky and I are presenting these, or unpacking these with the ARPDC sessions. Other jurisdictions are choosing something different. We chose the system after we went through the pilot all last year with teachers, and it seemed that the concepts and how things connected together worked well this way, but you don't have to teach them in that order. You'll find that Edmonton Public is using this order, that they're beginning the year with scientific methods like other jurisdictions are doing, but then they move to matter, and then they deal with computer science separately in the second part of the year, and then move through earth systems, energy, and finally living systems. There's a link there that you'll find in your slide deck that can take you a little bit more detailed into that Edmonton Public scope and sequence. Edmonton Catholic has something a little bit different. They too begin the year with computer science and scientific method, and integrate scientific methods and computer science into the other organizing ideas. And they, for their K-3 program, their scope and sequence begins with earth systems, then matter, energy, and living systems. And there's a link to the Edmonton Catholic pacing guides. And that pacing guide is a large PDF document, so you don't want to read it online, you want to download it. And it goes into quite a little bit more detail in terms of the amount of time and the length of time that would probably be needed to work with those organizing ideas as well. So those are 3 different ways you can unpack this and move forward in terms of planning for the year to come. Now, I just want to point out that word transfer again. Because as you integrate computer science and scientific methods into those other ideas, what we're really talking about is transfer. We're learning something, how to predict, how to do an investigation. And transfer is all about taking something that you know and applying it to a new context or new situation. So if at the beginning of the year, we use non-content methods of introducing scientific methods and computer science to the students, and we take them, we say, well, okay, well, let's do an investigation in living systems. Let's do an investigation in matter. They're applying those skills in different contexts. And that's where transfer comes in. And that's why we suggest to teach it early, so there can be lots of transfer activities throughout the organizing ideas. The big question is, excuse me, the big question is, well, how do we get to transfer? What does all that mean? And that's where we get to those phases of learning. So as a quick review, once again, that first phase is the surface level, and that's where we dig in and we teach the individual concepts, we teach the individual skills, so they know what they are individually. Quite often, this is where we stop, is just at that. We have quizzes that have lists of concepts and vocabulary, and we have students fill those out. And what we want to do, though, is get to that deep part. And as I mentioned in my last session, or the very first one, is that this is where we develop those understandings. We take those individual concepts, We relate them to those specific understandings, which is what the diagram is there. We see those individual concepts connected. And we begin having students practice identifying or working with those understandings in different contexts. And that's why I have the different colored backgrounds. Same understanding, but a new situation, a new context. Until finally, we feel they're equipped enough to do this independently, and we choose a very novel and unrelated context as we go along. So from going from deep to transfer, when you're in deep, you're already starting to transfer because you're giving kids opportunities to do something in different contexts and different settings. And finally, when you get to a full transfer, that's where you're looking at they're ready for a summative assessment. I think that they can do this by themselves. Let's see what they really know independently. And again, using novel and unrelated contexts. If you use contexts that you were teaching or instructing with, they're not really transferring. They're many times probably recalling what they did in a previous activity. It's great to share with you an analogy. Sometimes this kind of helps understand that a little bit better. I would like you to use a volleyball analogy just to get a little bit, maybe a different picture of what it means. We know that if you're ever taught volleyball before or played volleyball or taught phys ed, we know that there are certain skills, there's certain things that kids need to do. They have to know what a bump and a set and a serve is conceptually. What is that? They have to know how to do that. And then we start practicing that until they get good at that. And you know, if you've been to a volleyball practice, typically the first while you're just practicing these skills. And once the coach sees, oh, we're pretty good at those skills, then we can go on to some practice. Let's do some practice games. Let's put it all together in a game situation, guided scrimmages, and so on. And then finally, that transfer happens where now you're playing not just each other, but you're playing other teams. Maybe you're in a league and maybe you're in a tournament, still practicing those skills. As you know, you see I have an arrow here that goes back and forth because there's always an interaction between these. They're not discrete. Sometimes we have to learn a little bit more or add on to the surface level what we already know to move on. So that's, in a sense, works with the learning in science and other subjects as well, as going through those three phases of learning at a surface level, then really getting a deep, putting it all together at the deep level, and then applying that new learning to new situations. One thing, again, just as another example of the volleyball analogy, one thing I didn't include was that ready position where you're down, you're set there. Some of these things can transfer to very other parts. Ready position isn't just in badminton, but now we can transfer that understanding and that skill to new sports such as badminton or basketball or other sports that people play. So that's what we're going to look at today, is how we can move from surface to deep to transfer within an organizing idea. And we're going to be focusing on matter when we do this. Chris Zarsky and I, as I mentioned, we have already produced some videos and some sessions on unpacking living systems and matter. Those are available on the ARPD site. And those sessions and the upcoming sessions that you see at the bottom coming in later in October and November and February for those teachers who are teaching space, is we presented in that surface deep transfer component as well. So what you're going to see today is, in a sense, kind of similar to what we do with the other organizing ideas, but a little bit more robust because we have more time to focus in on just one particular learning organizing idea. So let's start taking a look at some examples, and we'll go through K-3 examples for each of these in the matter. And certainly along the way, if you do have some questions, feel free to ask, and hopefully, Angela, you'll keep an eye on those. I don't see my chat screen, so I'm just going to keep on going. So again, the surface level is that part where we take a look at individual concepts and the individual skills. And the question is, well, where do we get those individual concepts? Where do we get those individual skills? If I'm going to plan for my organizing idea, what do I pull out for that surface level learning? And for that, then we have to, again, look at our curriculum. So I have an example of the kindergarten curriculum here. This is the first cusp line. And as I referred to in our opening session, that what we do in our sessions is we refer to a numbering system. So in this particular case, when you see this, the K stands for kindergarten, M is for the organizing idea of matter, and we're working on the first learner outcome, And again, in science, there's only one. And then the number that comes after the decimal is the cusp line. And so this is the first cusp line in the kindergarten organizing idea for matter. And so to find out what concepts I have to focus on, I suggest we look at the understanding first, and the learning outcome. We could see in the learning outcome, we see properties, objects, we see property objects as well in the guiding question. In the understanding, objects, property, we see objects and property here. And then we see something about the similarity and differences of things here. Those are the key things we want to focus on. So we take a look at our knowledge and say, well, where are they located? Are they defined? What do I have to look at? Where are they? And when you highlight them, you could see that we already have some definitions for some of the concepts. We have an object here, properties, the definition is here. You'll see that in the understanding, the word identifiable property, not just property, but identifiable property is used. Well, what's that? It doesn't really say here, but intuitively we could say that if the students understand what the senses are, they use their senses to identify the properties. And we can identify different properties that are such as color and shape and so on here. So at the end of the day, we're going to use these things to develop these two understandings. You'll notice here that similarity and difference isn't there. It assumes that students know what similarity and difference is. So that may be another concept that I'll want to make sure students know before we move on. So it might look something like this. So if we go back to our graphic with the surface level and the concepts here, we can see that object, senses, property, identifiable property, and similarity differences are some of those things we'll want to individually teach that students can distinguish, know what an object is, which is a fairly simple one. What are the different senses? What is sight? What is touch, smelling? Can we practice using those? What is a property? But what is an identifiable property? What's a similarity? What's a difference? And work with those individually, and then we put them together in the understandings. Same thing with the skills. Where do we get those from? Well, we know that there are many skills in the learner outcome. You can see at kindergarten, these are all identified in the learner outcome, the skills and the learner outcomes. And you can see in grade 1 and grade 2 have certain skills identified in the learner outcome. We can come back to those skills many times at any time, not only in science, probably through other grades as well, to practice describing, practice interpreting instructions and so on, which are the computer science ones. So our learning outcomes have those skills that we can use, as well as skills and procedure statements. Again, you saw this graphic on our first day, and these are the most frequently used verbs in K-3 science, and you can see them identified here. Any of those are ones that you want to work at the skill level. If we want to work on having students discussing, we can build on that skill of discussing, because discussing is probably one of the most powerful ways for students, especially at the younger grades, demonstrate what they know and understand. So what are the characteristics of a good discussion? You know, we'll start earlier. Here's the rules of a discussion. How do we expand our discussion and learn about how to discuss as the year goes on, adding layer upon what makes a good discussion and how to use that. Nonetheless, so there are a lot of skills, and in this particular cusp line, you could see that explore, describe, and sort are the key ones that are being used in this particular cusp. So if I'm going to have kids explore the properties, we have to know what explore means. In this sense, really, they're looking at observing with our senses, right? If we're going to be using one or more senses, we're going to be observing to find the properties. And then we're describing. What does describe mean? How do I describe something? Sorting is another one, and then comparing. Well, what does it mean to compare? And so students to have practice at the surface level doing these things as well. So if I was going to plan for this, I may look at something like this, a surface level quick planner. If we take all those concepts that I identified in that previous slide, you'll see them listed here. And you may want to do some pre-assessing with that first. Do students know what an object is? Can they define what it is? Can they distinguish between sense and touch and so on, and the different ideas and concepts. So we would make some pre-assessments, not only for the concepts and the skills, but with the skills as well. Now, when it comes to the skills, these were the ones taken right out of the curriculum, but I might wonder, maybe are there some good, can I integrate any of those computer science skills into this? And I may would list them here. Or maybe my scientific procedure skills, what could I use here? And then once again, pre-assess, how do I know their level of proficiency in this? So I'd have some pre-assessments to find out where they are. And once I do know where they are, then I can begin my instruction. So this is the same planner as above, but I filled it in with some sample activities, and I'm not going to go through them all. Many of these are filled in with chunks of the slides that Chris and I have already presented. So you can see this is slides 24 to 26. So if you go to the ARPD site and take a look through the new science curriculum resources and find our presentation there, there's a slide deck associated with our matter presentation. And they look something like this. And there'll be some activities that Chris will have gone through that will tell us how we can, some different ways we can work with the senses. And those are 2 slides that she used to introduce senses into the program. Now, one of the example here, I have it highlighted here. I'm going to take you this example, and this example is a surface level example of how to maybe introduce, in this particular case, property or observable properties. In order to do that, I'm going to use something called the concept attainment lesson, and maybe many of you already know what a concept attainment lesson is. If not, I'm going to just take a couple minutes to take you through one. So you can get a sense of what, if you do use concept attainment, you'll have a sense of what students are going through. I'm going to present to you something called a ziggurat. And I'm not too sure if any of you saw this before or not. I had the good fortune when I very first started my career, in my very first teaching position, piloting a new social studies program, and it was just happened to be very much ahead of its day. It was a concept-based social studies program, and my training when I was piloting it went through how to work with concepts within a concept-based curriculum. I had the good fortune of learning that and helping Sask Ed do some implementation sessions with a concept-based curriculum. And one of the teaching strategies to help introduce concepts that I found is the concept attainment one. So I've been using the same lesson introduction for many, many years. So if you've seen this before, I do apologize, but it's one that gets people thinking and really helps people understand the power of a teaching approach such as this. So in concept attainment, we begin by saying, we're going to find out what a ziggurat is. And what I'm going to do is I'm going to give you an example of a ziggurat, and it's going to show up in the yes column, and a non-example. The yeses will have the attributes, the characteristics of what makes the ziggurat. The no's are going to be missing something. It can't be a ziggurat. So I'll give you an example. An O is a ziggurat because it has all the characteristics of a ziggurat. A no is not because it does not have all or some or all the characteristics of the ziggurat. So you may be thinking of something already when I show you this other example. If you, I would tell the class, if you have an idea, don't blurt out what you think the characteristic of a ziggurat is, but if you can, just provide an example and we'll decide whether that's an example or not. But a use it as an example and an R is not. And some of you are probably already hypothesizing what a ziggurat might be. Here's another example. C is a ziggurat, but an A is. And those of you who are perhaps thinking, well, they're vowels versus consonants, well, we're wrong. Now, you can see the power that now kids are doing a lot of those things we talk about with computational thinking, where we're analyzing, we're taking a look at characteristics, we're problem solving, we're predicting, and now we have to change our prediction because what we see, the data is changing, so now we have to change some things, right? So it's no longer an A, but what is it? What could it be? Well, what do all the yeses have in common? What makes them that? Why doesn't the A, the R, or the L fit? What is it? There's another example, V. And again, people going, oh, probably, oh, I thought I had it. I thought it might have been something that a letter that was made with curved lines. And well, because the O, the U, and the C, they're all curved lines. The A and the R and the L were not, but a V is not. So once again, we got to change our thinking. And those of you who are thinking that they were letters that you can make by one stroke of the pen, well, now we have to change the hypothesis again. It's not there. But what if I asked you this, where would you put a W? Is a W a ziglot or not? Based on what you think. It is. It has what it takes to be a ziglot. How about a D? Nope, it doesn't have what it takes. Okay, what's a ziglot already? It's quite interesting when I do this. It's always the younger audiences, like not even primary students, who kind of get this, and the older people they'll go through the older students and adults. We have a tough time with this one. But when you take a look at it carefully, a ziglot is simply a letter of the alphabet that looks similar in both upper and lower case. So how about a P? Is that a ziglot? Again, it would be a good discussion, because if you were to have that discussion, or whenever you give an example that's kind of gray in a concept attainment lesson, say, now where does this fit? You'll notice the discussion is going to be talking about the attributes of that concept. That's what we really want them to understand. And we really want them to dig deep. We know when they're having this conversation, if it's an example or not, they're talking about the criteria, which is at a deep level. And it would depend, right? If we consider the line of where it is, above or below the line, we could say it is or isn't. You can introduce concepts that way. You can also introduce them by starting off with a sort. Many of you are familiar with the sorts. We could just take these letters and say, look, sort these letters into different groups. And they may organize them like we already did. Like some of you maybe already did. We were going through the activities, vowels versus consonants, or curved letters versus not, and so on. And we could do that way. But when you do that way, you don't think, well, I want to develop the concept of the ziglot, so I'm going to do a sort. The question is, well, you have to be prepared that a group or none of the groups or students may not sort them into the way you want to ziglots. So this is really good to get kids to sort, to think, to focus on criteria and attributes. And after that, if none of the groups come up with that sort, then you can give them the sort. Well, here's the way I sorted mine. What is there that they have in common? So you can move from a sort to concept activity as well. So there's just a couple of surface level activities that can be used. And so in this particular case, if I want to introduce the observable property or identifiable property at kindergarten level, I'm not too sure if this will do it, but this is a concept attainment lesson that may be helpful in doing that. Or if it isn't helpful, or is it maybe a little bit too complicated at kindergarten level, it might trigger some ideas for you at the kindergarten level where your kids are at. With each of these concept attainment activities, I give a little bit of a lesson step in terms of how to prepare for one and how to go through one. Now, for this particular one, students need to know what senses are, what an object is, what an observation is, and what a description is, because those at the end of the day are going to be used in this. So before I get to talking about properties, you'll find that it'll be really helpful if students know this. But then again, you could give them an image or give some examples. You can have it, instead of using the slides, you can have some stuff right there, and then give some descriptive statements. For example, this object has a shape and a color and a size. Those kind of statements are different than the other ones where I say the object is square, the object is brown, and the object is the size of a football. And I would address how they move across. So an object has a shape is I'm talking about a property there. This is a statement that talks about a property, but this is a non-property statement. The object is square. So shape is a property, square is not. What's a property? And I'll go to the other ones. I'm identifying properties with these statements. The objects have a shape. The objects have a color. The objects have a size, and so on. I'm getting into the description part with those. And you can see they go through examples and non-examples. And finally, we get to the idea, well, let's talk about it. A property is what objects have, or the characteristics as defined in the curriculum, that we can describe. So a property is something that an object has that we can describe. Well, let's take a look at those other things. An identifiable property is something that we can observe with our senses, because I've already taken senses, and I can describe it. Well, let's take a look back. Can I, here's like what I described with my senses. I'm using a sense here to get those as well. So identifiable properties are ones we can see, properties we can see with our senses. So they're not the particular details of the property. They're what the property has, or the image or object has, that you can describe. It's not the actual description. For example, and you can give more examples here, the campfire has a size, or the campfire is small. Which statement describes the property or identifies the property? Well, we know it's the first one, because it's something that we can describe, and the second statement is describing the property already. So it's a fairly difficult concept. So it probably would provide many examples and non-examples and practices along the way. But I guess what I'm getting at is doing those examples, non-examples are often a good way to help students to learn that. And we can see why we want students to learn that at a good surface level, because if you ask students to describe the properties of objects later on, which one of the learning outcomes are, they'll need to know what a property is in order to do that, right? And same when they compare properties, right? They'll have to say, oh, I'm going to compare property based on its size, or compare objects based on properties. I'm going to compare it on its size. I'm going to compare it on its color. So they're identifying the properties as criteria for their finding the similarities and differences later on. I'll talk about that one perhaps a little bit later. So again, at the surface level, this is something you do at kindergarten. Very quickly then at the other grades, again, we see that objects, again, a concept used here. Property shows up again, but now we're not talking about observable properties or identifiable properties. We're talking about measurable properties. And there's examples of what measurable properties are here. The skills are going to be using tools. And here we are comparing, similar to what we did in kindergarten with finding similarities and differences. And I've highlighted the word identify here, excuse me. It's a tricky word. I made it yellow because you have to interpret it in a certain way, and that'll decide on the activity that you may use. If you want kids to just recall something, we could say, well, what are measurable properties of objects? Well, length, area, and mass are measurable properties. Versus maybe saying, look identify the measurable properties of this object and give them a brick, and they have to actually identify the measurements of them, identify the length, and so on, which are two different skills, I guess you could say. So at the bottom of the slide, you'll get the slide deck with these things. Here's an example of the grade 1 planner. Once again, I included kindergarten with this because they may need to know these things before we get into this grade 1. So here's the concepts from kindergarten I included in with this. And the measurable property is the new concept that is being added on. Again, some pre-assessments. Do students know what these are? If they don't, at the kindergarten concepts, they are unaware of those. After our pre-assessment, we'll have to do some teaching, and they likely may or may not know these things as well. Once again, we're going to compare. This time, we're going to be using tools like balances, rulers, and so on. Do students know how to do that? We're going to have to do some pre-assessment and plan some activities to find out. Are they going to be examining things? In other words, really, it's an analysis. They're going to analyze it and come to some kind of understanding about the object. Are there any computer science or scientific methods or other verbs that we can use other than compare to develop those things? That would be all in the pre-planning. And I filled one out for you here as well, as I did with the previous one. Again, some examples from our previous presentation with Chris are in here. And maybe I'll show you another concept, attainment one. We know we're talking about similarities and differences in kindergarten, but we're also comparing in grade 1 and grade 2 or grade 1. So what are similarities and differences? And then again, you can see that there are some examples here. I've got two creatures here, and then through my examples and non-examples, I'm going to give statements that are similarities and statements that are difference. And you can see how they progress along the way. Again, it's not necessarily the intent that you take the slide deck and use it, but maybe use it as a thought for something, and other activities that you can use to introduce some of those concepts so that kids know what they are before we go ahead and start working with it in a deeper level. And finally, grade 3 or grade, so let's quickly look at grade 2. In grade 2 of the first cusp line, the key thing here is that materials, and we're talking about combination, and we're talking about objects as the key concepts. And you can see that those concepts show up here. Materials are used to make objects. That's the connection between materials and objects. And so we're specifying objects as a fairly broad term, but any object can be a material if it's used to make something. That's the concept we're trying to understand there. But they are also related to a purpose. And you'll notice that purpose shows up in the guiding question. It shows up in the learning outcome. But this particular cusp line, purpose does not show in the understanding. It shows up here as well in the skills and procedures statement, but it doesn't show up here, nor is there a definition of it here. And this is the first time in the science curriculum where students are exposed to purpose. It's a key concept. It's up here in the learning outcome. So I would want to make sure to include that as part of my learning so that students understand what a purpose is. And here, the skills, here's that identify again, and I'm going to interpret it as analyze. Identify the materials used to make various objects, or you're going to analyze the materials to conclude what objects they are made in. So I'm going to focus on the word analyze there. And here's a quick planner again for this surface level. Once again, you'll see that I included the kindergarten concepts, the grade 1, and now the new grade 2 concepts of materials and purposes. This is blank for planning if you want to use it. And then once again, I'm going to work with analyze and create here, because those are the words that do show up in the cusp line. And then some example activities that are associated with those that you may want to use for this particular cusp. Again, another concept attainment, I'm going to, skills I'm going to have to, one of the skills is to analyze. Well, I'm going to use another concept attainment example for you. So to introduce an analysis for students, because when you're analyzing, essentially you're creating an analysis. So if you know what an analysis is, then it's a lot easier to analyze something. So really quickly, I'll show you what this is. Some background information. Students need to know what criteria a conclusion are. Conclusion is one of those scientific methods ones that's taught in grade 1 already. And so we're introduced in grade 1. And criteria isn't introduced anywhere, but when you do take a look at the competencies and decision-making for grades 1 to 3, and that's again in the New Learn Alberta, where those competency progressions are. When you take a look at the competency of decision-making, quite clearly, the word criteria is in there. And one of the competencies is that students use criteria to make decisions. Not in this packet, but in other ones, and available to you through the ARPD site, is a concept attainment lesson on criteria. What is a criteria? So you can use that perhaps. And I also have a concept lesson on conclusion. So anyway, what's an analysis? So again, this activity goes through that same example, non-example. This statement is an analysis. The book are organized. This is a non-example. The shelf, a bookshelf holds books. We can see that the shelf that happens here, but this is an analysis. This is not. And with one like this, you'd want to have the examples showing all the time. So using a slide deck like this may not be the best thing, may actually having the images and all posted so that they can see all the images and all the statements together may be the best thing. And once again, we go through examples of an analysis statement versus not. I'm not going to go through all these examples with you. And then you finally get to what is an analysis? Well, it's a conclusion after close examination of something using certain criteria to understand it better. It sounds lengthy, but we know what a conclusion is already, so that works. And we're using criteria to focus. So what criteria to make this statement? There are many kinds of candy bars. What criteria would have used? What was help you're focusing? Were you focusing on color to make that? Were you focusing on the name to make that analysis that there are many kinds of candy bars, or the shape? And it might have been all the criteria. You know, there's different names of these candy bars, which is probably what I really focused on when I was analyzing. Remember, an analysis is looking closely to make a conclusion. So by looking, I see there's all the different names. And so that's why this is a good analysis statement, that there are many kinds of candy bars. And same with here, the analysis that people are at a park. Well, if I analyze this carefully and I use the criteria of objects in my environment, I can see there are trees, there's some maybe water here, and maybe if I make this a little bit bigger, you'll be able to see that. By analyzing this photo, I can conclude that conclusion of my analysis is that the people are at a park. So that might be one way you may want to introduce it. But the whole point of this is that we're introducing the students to these words and these concepts at a surface level. You notice I didn't use any course content in any of these examples. I don't want them competing with that. I'm not going to do that. Once they know what analysis is, then I could start having analyzed stuff related to my course content. And finally, grade 3, once again, similar kind of thing. Identify the key concepts. Here we got matter itself. Heating and cooling are the key things here. Matter is defined here as the states of matter. When we're talking about heating and cooling, we're going to be talking about these things, so they become important as well. You'll notice here we're talking about as well investigation as the skill, and discussing as the key skills as well. So if we take a look at a key planner of how we might plan at the surface level, I'm going to have to move. I'm looking at my time and I think I'll get done. Let's go here. So same kind of a thing. I didn't include all the other skills or concepts from the previous grades, but you can go back to see using the same planners that you'll have the link to see what was taught previously that you may have to make sure students know to get these work with this particular cusp. And again, the 2 key skills, and then some examples of how to work with those. I'm not going to go through this, but we're talking about purpose. There's that also is in here, and I used it as an example. Like I won't click on it. Same kind of thing. We're looking at examples here. If you want to make a conclusion or observation, we have discussion checklists, for example, here. If we're going to teach a skill, this is for Division 1. You know, if discussions are important ways to share information, discuss information, let's take some time and learn what discussion is, and maybe discuss things not related to science necessarily, but discuss things that are happening in their world, their lives, and have kids practice these things individually, know what it means to respect or contribute, and then putting them all together in a checklist and say, look, you know, as you guys work together today, I'm going to be listening to discussion and I want to see these things. Of course, this could be a very long progression thing. It's not going to be something they're going to learn in one lesson. But we want to start introducing these things and reminding them at the surface level of what we're going to be looking for when we discuss in this organizing idea. Oh, moving fast here. So those are all different things we can, again, focusing on the skills and the procedures, or skills and concept at the front end, getting them together, knowing what they are individually, because when we get to the deep part, this is where we're combining it and putting it all together. So remember, this is the graphic for the deep. We have the connections being made between the individual concepts. For example, objects may be similar, maybe similar in one or more properties and different in another property. So we're talking about objects, similarity and difference, and maybe a fourth concept, properties, right? And again, we can have kids take that understanding and apply, are objects similar and different based on their properties using these objects? Let's change the concepts. Let's use some different objects and see if they still have that understanding. Let's use these objects and make the context increasingly complex and novel as we go along. That's what we're doing, working with the understanding, but providing different concepts. Now, this graphic looks confusing. I don't mean it to be, and it's not the most attractive and pleasing planner, but I just wanted to point something out here. When we take a look at the skills and procedures, you're not necessarily working at the deep level with all these things. For example, we're to sort objects according to properties. That's a fairly basic surface thing, right? We're looking at the objects and categorizing by the properties. And that's what that knowledge piece, that all objects have properties. If I was to work at this one, this is working at the deep level, working with this understanding, right? Explore properties of various objects using one or more of the senses. Now, I'm working with the concept of objects and identifiable properties. I'm making the conclusion, well, all objects do have identifiable properties, all right? Is that true? In all cases, and you'd give them different contexts. Objects may be similar in one or more properties and different in another property. Is that true in this context with these objects that I have here? Let's provide a new context. Is that true that, in this new context, that things can be similar or different, and you provide different contexts all the way along the line? This may be working with things that you bring in the classroom. Maybe by this time you're in a grocery store, and the context can change that way. Same with when it comes to grade 1, again, objects have measurable properties. This is the understanding. Again, looking to here, the only skills and procedures that is connected in this particular case to the understanding is this one. So if you do this and have kids come to this conclusion with your comparing and contrasting, you're working at the deep level or at the understanding level. So directly compare and contrast the area, length, and weight of various objects. And after they do that, you'll want to ask the questions. Is it true that all objects have measurable properties? Well, yes. And do they all have similar properties? No. And you can make other conclusions, right, based on that. Now you're working at the deeper level. And once again, when we get to grade 2, we're talking about materials can combine a variety of ways to make objects. And this is the skill and procedure directly related to the understanding. So if you get kids to do this, you'll be working at the deep level. Same with this. As soon as you're conducting an experiment and you're going to be an investigation and coming to a conclusion, you're going to be working at the deep level and making an understanding. So from here, we can move from some certain matter from one context, and perhaps we could change matter and environments in these new contexts. Once again, when we're talking about heating and cooling, and just that whole question of supervision and safety is important. Perhaps in many cases, you find really good videos when we're talking about melting points of things that is impossible to melt in a classroom. So those contexts can change as we go along, from something in the classroom to looking at different videos and case studies that way. So moving from surface to deep is simple matter, putting these ideas together and creating a new context, but you're working at the understandings, you're working at developing those. Another really good activity at any grade level, but more particularly when the students can start reading, is to put together concept maps. But I suppose kids can do concept maps if they have pictures in here. But concept maps are really good activities to use to help you know whether kids understand the concepts, and to help kids to really think about the concepts and to work with them at a deep level by connecting them. Because as we know, the deep level is really making connections between the concepts and how are they all related. So students may know what a property is, what tools are, and what these individual things mean. But if you were just to give students these little pieces of paper, and this would be maybe at the grade 3 level, with these words on them, and of course you'd want to practice concept mapping first before you do this. But if they're familiar with how concept maps work, they can say, arrange these in a meaningful concept map. And it may look something like this. It may look something a little bit different. But the key is to have students state the relationship between it and put the words and say it as a story. For example, objects have properties that are measurable. and we can measure them using tools. Some measurable properties include length, area, and mass. And once that can be done, you know that there's an understanding of those concepts and there's a deep level happening there. This is an example. Just the other day, I was working with my wife helping with the language arts one in the new curriculum to develop a concept map. And I had a hard time because I really had a hard time distinguishing between text form and genre. And until that became clear to me, I could not put the concept map together. So it would really highlight to me the importance of making concept maps, because you can't make a good concept map and explain it in a logical form if you don't understand the individual concepts. And let's very quickly then talk about the transfer phase and some examples here. Remember, the transfer is really an extension of deep. That's why I have the dotted line here. The transfer is maybe what you want to sum up with. It could be a summative assessment, or it could just be deepening in their learning till they become more independent and transferring. So depending on what your goal was, but quite often transfer activities are summative assessments because you're giving them students a novel context in which to work and working independently. So the only thing is changing again is the context. And you'll see the word that I'll use often is a novel context. And the transfer literature talks about a novel context. You can't have students demonstrate transfer in a context that they've used before because there's depending on recall. It's got to be a new context. The more complicated and unrelated the context is, the greater degree of transfer. But of course, there's more complexity there as well. This is quite often where project-based learning comes in. So we do all the surface stuff and we learn about the skills and we learn how to use tools and we learn how to do that surface level. And we do our practicing here in different environments. And now in our project-based learning, here's our problem, right? How are we going to make the school a cleaner place if that's related to the concept you're doing? So you think of that project, but now you've practiced all the skills and concepts and understandings they need to know to go ahead and move through that project quite easily. And you're not stalling and saying, well, okay, here's how you make a graph. Oh, here's how you make a chart. Here's how you use this tool. That is already done at the front end. And now they're just focused on that great problem that's really got that authentic problem that has them fired up, but they have the tools, the knowledge, and the understanding to make that project work. I remember when I first started working with project-based learning, it was floppy simply because I didn't do the surface deep. I thought, well, I'm going to use my project-based learning to teach everything. And we would just get bogged down and kind of you lose interest in the project and you keep bogging down and having going back to reteaching. So you do this front end surface and deep stuff first, and then the project-based learning likely goes a little bit smoother. Not to say that there's not any going back and relearning and reteaching. There's going to be some of that, but you'll want to move that forward. You want to make sure you get as much of that done in the front end. Here may be an example of a transfer idea. If we're talking about matter again, let's try a field trip, right? And they go to each location using their 5 senses and maybe noticing objects in their environment and what they are. And they can somehow record these things, or as you're going through, you record them and take pictures of it and have students fill in a chart or something when they get back. But you can see how, again, going into a field trip and giving students a task, working with their understandings of concepts in different contexts is a good way to wrap up in something like that up. Grade 1, maybe here's another idea. It could be a packaging problem where you give students a variety of things that they have to mail in this container, and they have to describe the properties of each and figure out which containers, which objects may go into that container that could be sent off. And again, there may be that you get into grade 1, there's some talk about physically change things, so they'll maybe figure that out as they go along. But it's giving something like that, giving the students problems where they have to put all their learning together, and work with something or solve a problem in this particular case. We're talking about maybe perhaps doing a STEAM design challenge. We're talking about properties and properties at grade 2, once again, are can be used for a purpose to build things. Well, you can maybe talk about the 3 little pigs and have students test which materials would be good to build certain wind resistant structures out of, using of course the 3 little pigs as the idea to begin with. And then again, when it comes to grade 3, this is an interesting one. This idea comes of integrating language arts by writing a story or a cartoon about how the whole story of matter, right, and melting and freezing points, and how all these ideas can be built into the story. But as you explore each cusp line or activities, you kind of begin the story, and then you can go back to the story as you keep layering on your learning as you go through the cusp line, and that could be another way to perhaps do that. And that's generally then is the way to go through a surface deep level program, using matter as an example in this particular case. We could do the same thing with computer science. You can do the same thing with scientific methods. And it's probably a good idea to, again, if you think about that whole process of surface deep learning, if you take that computer science and do the things that Angela did at the start of the year and then integrate it, you can see how integrating becomes transfer, because you're learning at the surface level specifically with the computer science organizing idea, and then integrating it or finding a new context in the different organizing ideas. And same with scientific methods. Now, I'm going to show you these links. This is the planning template. It's just a year-long planner. You may want to model what Elk Island or the Edmonton Catholic schools or public schools did, those scope and sequences that I showed at the start. But if you're interested in planning, here's a document that you can download and begin planning your year with this. And there's one for each grade in here. So feel free to make a copy and download it. It's preloaded with the organizing ideas. And once again, you can decide where you may want to be and what you might want to do for your organizing ideas. Whoa, I went way ahead of myself here. And once you get the year planned, then you go into organizing each organizing idea or planning each organizing idea. And that previous plan that you saw, Jess made that, and she also created these that you may do as well. She's got it here. This is blank right now, and what we'll do is maybe I'll throw these links into here if we have time to work on these together for a little bit if you want. But what she's got here is the organizing idea, the outcomes in terms of the cusps, I guess, are already preloaded in here. And then this is where you can put some assessment strategies, resources, and what are some local and nearby options for that experiential learning and excursions that can be used at the transfer. It doesn't have to be the transfer phase, but quite often we know those experiential learning things are more the transfer phase, but they can certainly be used at the front end at the surface level as well. You'll see this is pre-filled in, and what Jess did with her first session gave teachers a time to download this doc and add onto it, or go to the link and add onto it. So what you see here is not done by ARPDC, but is done by teachers just putting things in from the last session. If we have some time here, shortly I'll give people a chance to do that. But you will have these links available to you. And you can fill those in if we have some time. Again, each one has a whole set of things. Some have more than others, but you'll have already some ideas that other teachers have put in that go along with each cusp line, and it could be a helpful resource for you. But it's a good way to help organizing that Similar to that, I'm just going to point out I quickly showed this to you in the first session. What you're going to have available fairly soon available to you is something similar to what Jess produced. It's a document that looks like this. It's going to focus in on each organizing idea. It's going to have a summative assessment idea right at the front end. In other words, a wrap-up activity at the front end. Because once we know what we want to do at the front end, here's how we're going to assess summatively. Now we can plan to make sure the kids and the students know, or children and students know, what they need to know at the surface level and at the deep level in order to be successful in the summative assessment. So with each cusp line, you can see that there's a link to cusp line 1, cusp line 2, cusp line 3. Each cusp line planner part looks like this. It's going to have associated I know and I can statements. It's going to have prerequisite knowledge for this cusp line that students should know. And it's going to have the key vocabulary associated with this particular cusp line. And this one, we're taking a look at living systems, which isn't a kindergarten one. I apologize, I don't have that example, but there will be one available for kindergarten with matter and all the other organizing ideas. In this part here is the vocabulary and the concepts. These are the ones that are identified. Someone had posed the question, is there going to be a list of these in a glossary? Well, I'm starting to put one together. So here are all the key concepts or key words for the entire grade 1 living systems organizing idea. These are the key concepts right here. There are definitions here that we provided their source. And sometimes if it's an Alberta Ed source, here's where you'll find it, which curriculum, and in this particular case, it's science, kindergarten living systems, first cusp line, and the first outcome is where animals is defined. If there's a sample introductory activity, it'll be provided there as well. This is a living document. We're just started, it's growing, but that'll be linked into the planner that you're going to have available fairly, not planner, but support document soon. You can see some of the things that I've already had shared with you today are going to be linked in here as well. I'll just get out of there and go back to the planner here. So there's going to be that as well as a link to then the different verbs and examples of how to introduce the different skills, such as compare, contrast, and so on. Then associated with this is some sample activities of how to teach the different components. This is broken down, though, in a way that is a little bit different than Jess's. You'll see here that we took these knowledge components, but we didn't include any understanding or skills and procedures. There is no skills and procedures activity in this cusp line to help produce these or assess these or to introduce students to these. So here's some sample surface level activities. Here we're working just with the knowledge, those particular individual pieces. So that's at the surface level. You can see here, we're working with an understanding. Here's one of the skills and procedure statements at this level. Here are some example activities to help at the deep level to attend to this understanding. So that's how this is going to be organized. Here we've got some knowledge pieces, and in this particular cusp line, there is a skills and procedure statement that helps to focus on these things. So we can use this as the foundation of our activities, and then you'll find some other support activities. And below that will be some resources, and if there's some links to gizmos and things like that, they'll be included as well. So you'll see that coming fairly soon. Within the next couple of weeks, we hope we'll have the living systems K-6 done, or grade 1 to 6 done, and matter K-6 that will be done as well in the next couple of weeks, we hope. So you'll see that advertised through the ARPD site. I just want to speak briefly about triangulation, or not triangulation, assessment. I think it was maybe Nicole, but maybe Angela, it was you, when we're talking about assessment. We don't really have to change too much what we do. We do the similar things that we do now with formative assessment. We do that triangulation, and we talk about observations, conversations, and products. So we give students any of those surface level or deep activities. They become assessments. So they're not just instructional activities, but they're an assessments formatively. If you watch and you take notes and you observe and you have a conversation with students, you're going to get lots of information about what they do. And then just remember that some of those transfer activities can be summative assessments. So you may be doing all these things as students are doing those summative or those transfer activities as a summative assessment. You can get lots of information. Consideration number 2 when you're planning assessments as well. So not only do our learning activities as they are in the cusp line where the skills and procedures things, those can all be used as assessment activities. But we don't have to be just using those. Remember, we can use in the guiding framework, the definition of skills and procedures are what students do to demonstrate what they know and understand. And so if we can take any of those skills that I showed you earlier, that those frequently used verbs, we can use any skills and procedures and have students do those things with the understanding or with the knowledge and concepts of an organizing idea, and make assessments using the other verbs, not just the ones that are in a particular cusp line. Let's keep that in mind. This page, I'm not going to go through it. You'll have a chance to go through a little bit deeper, but here's just some questions to know whether you're going to be assessing at the surface, deep, or transfer. So we know if you're asking for the definition of something, you're working at the surface level. You know, what is the material? What is the purpose? Maybe if they can distinguish between 2 different concepts, we're still working at the surface level with the concept. What's the difference between a description and an observation, for example, right? They may be able to tell you that. For working with skills at the surface level, you know, can they keep, you know, sometimes you have a list when you're doing an investigation, for example. Here are the steps. What are the steps? Describe the steps, what they're doing and what they are. Can they follow through in a simple investigation with that guide there versus when we get to the transfer, they're doing these things, those skills independently. We're at the deep level when they can create those relationships between these individual conflicts. We're working at the deeper level when students can provide justifications for the connections that they made. We're working at the deep level when they can distinguish between non-examples of the concepts. For example, the concept attainment activities that I did, if you, as an assessment, say, you know, is this an example of whatever concept it is? Why? What do you think so? Or in this picture, you know, can you see these concepts we took in class? In what way? Those are just some simple things. But when you have kids generate and distinguish between examples and non-examples, you're working at the deep level with the individual concepts. And you do the same things with understandings as well. And can they make connections between skills and procedures? Like is comparing and contrasting similar to observing? How are they different, right? So you could talk about the skills themselves at a deep level. And then transfer. Can students take a new situation and relate their understanding to it? And they say, you know, for example, all objects have measurable properties. Is that true in this situation? Now we're giving a new context and having students demonstrate understanding. So these are just some questions to keep them back into mind to see whether your assessments at the surface, deep, or transfer level. Once again, I showed this activity or this slide earlier that has links to a variety of different resources. The Edmonton Catholic's curriculum crates has a lot of activities in it as well that are associated with each of the organizing ideas. So that's very specific to this new science curriculum there. You may want to look at that. Of course, our PD site, I went through that a little bit very quickly. I'll show you that once again. When you go to the new curriculum resources, we suggest that you take a look at, put in your grade level. If I'm at grade 1, you'll see that anything related to grade 1 science is going to show up here. Right here, we've got our computer science activity done by Angela. exploring grade 1 computer science. So there's a good resource for you right there right off the bat. This is the matter session that Chris and I did earlier in the year that it's kind of parallel to what we kind of covered today. And you'll see one for living systems as well. All the teaching resources and all the slide or the links and everything that we have are all linked in together as well as the slide deck. So that's available to you as well. And there's some other places that have very good learning activities as well. I'm not going to click through them all. I'm 15 minutes ahead of time, but I know that I moved quickly and that may have caused some questions to pop up. I have been keeping an eye on the chat, Angela, so I don't know if there's anything that I may have to address for people right now.
I do have a list of questions that I've been
Okay.
recording, and someone just asked if you could just back up one slide on your presentation.
Let's do that. Sorry, I knew I had a lot to cover, and so I just went
It's all good. Well, there's these questions could take. So I'm in the first question that came in, and now I did not pay attention to whether or not these were covered later on in the presentation. So the first was from Marlo asking, when teaching a combined grade such as 1-2, how would you suggest teaching / planning for science, as it is very difficult to cover all of the content?
Yeah, it is very difficult. And Chris Zarsky and I, who is another ARPDC, is part of our science team as well, we're going to be looking at putting some sessions on for that to help with that. But that doesn't answer your question right now. It depends how you're teaching a split class. Some jurisdictions allow teachers, especially if the school is small and there's not a high turnover rate, to flip-flop between teaching grade 1, for example, 1 year, and grade 2 the next year. But that becomes difficult if there's a turnover of kids, because you have kids coming with gaps. So my suggestion that if you're doing one or the other, I would say the best help I could suggest right now is to look at the common features, look at those big ideas, concepts. For example, we know property is a big concept in both kindergarten, grade 1, and grade 2 as well, and all through those primary grades. So, how can we work with that and introduce it, but then once you introduce it with one grade, take it to that next level. So if we're talking about properties and what you could observe, and that'll be a kindergarten one, but grade 2, well, let's continue to talk about properties. What are they? Well, which ones can we measure and add on to that? So the grade 2s can listen in, for example, to that conversation, because they're going to need to know that anyway. But now with the grade 2s, well, the grade 1s are doing their activities with observing things and observing properties, for example, and making their description of that. The grade 2s can be introduced to their measuring components as well. So the concepts can be good, helpful in a way to maybe make sure that your conversations with each grade doesn't have to be too different. There's a common link between them. In terms of the pacing, I really don't have an answer for that right now. I apologize. But I'm thinking, when I look at this, using this sort of the organizing idea and the concepts of the key organizers, I think it's going to be a little bit easier to teach a split class, because they're not so teaching two different things. You could introduce different skills when you're talking about, for example, discussion. You can have everybody join that, right? Here's what a good discussion is, right? You can have both grades teaching it. Here's how we compare. Here's how we contrast. So the skills, you can include everybody. The concepts are just going to be adding on a little bit. Both grades can sit in at the introductory level, and then at the older grade where you add on to it will be a separate thing. I hope I answered that. That's the best I can do in sort of with the information that I have in front of me right now on this slide.
I think that was a great answer.
Next question.
Next question. In your opinion, should each cusp line, so I guess each row of understanding is what they're asking, have it be a unit, or should it be a whole organizing idea as a unit?
Well, I think it goes back and down to is what information we want to get for getting enough information to help with assessing learner outcome at the end of the day. So all the cusp lines contribute to providing information to making that assessment for the learning outcome. And it depends on the cusp line as well. Some cusp lines are really quite fundamental. And so you may want to go through a cusp line and assess that formally at the end. And you'll get a sense of when you look at them. Nothing's coming to mind right now, but when you look at your cusp line, see, this is the key one that's really connected to the learning outcome the most. And then teach that as a separate thing. I would kind of go through teaching them separately to make sure that they have the understanding, but some will take longer than others. Some of them you may assess the understanding, pre-assessment, and they already know it. Some of them are fairly straightforward. But yes, I would teach each cusp line individually and do some kind of a formative assessment or summative assessment, depending on how big that cusp line is at the end of each one.
Excellent. Someone was wondering if there's a document with the skill verbs that's going to be shared that explains each of them.
Absolutely. And that's even further ahead in development than that concept one that I showed you. It's going to be linked into that curriculum support document that I showed you. Just really quickly back here. I think it's right here. So here's where I had the list for the different vocabulary and concepts. We're going to have one for the skills verbs right here. All right. And that's underway too. So hopefully when we publish this, that skills thing will be there available to you. If it's not there, it is being developed. So let me tell you that for sure.
Excellent. Oh, yeah, this one's a longer one. What are your thoughts of switching science lessons to be taught to do the unit all at the same time, rather than having like X amount of science classes per week and X amount of social, and then so switching to do a unit of social? So, flip-flopping, doing all science, then all social. And then someone had added on, just saying that they were also curious what your thoughts on that were.
So maybe I don't have that question in front of me. So just maybe to clarify, so is it sort of teaching like a regular schedule? A day has some science and then social studies and so on, or taking a block and then teaching that and then leaving science and coming back to the social studies?
Yeah,
and so on.
That's exactly what it is. So say September, we're doing just science, and then in October, we're doing just social, for example.
That it really depends on your students. That anytime you leave the learning for a while, like we know that 2 months over the summer can disrupt learning. I don't know. It depends really on how much maybe you integrate. For example, I would focus on what are the skills that I'm going to be in science? Am I going to be doing investigating, analyzing, a lot of those things, discussing, comparing? If I'm going to use that in my social studies and I'm going to continue to practice those skills, then that's fine. There are some concepts in science, for example, change. I'm trying to think of some other environment, and some of those concepts that maybe in science hopefully can find their way into that social studies, so that if I can lead the science now, we develop those concepts, but I can also integrate some of those into the social studies when we talk about it. Then I think that's a great way to do it too. My personal way to do it is if when I do it, I take, because it's a concept-based course, I would integrate. I wouldn't have separate things. I almost do my project, do my introductions that I need from social studies, make sure that I've got some key concepts there and some skills and language arts, and do a project-based learning or inquiry thing where I'm doing all subjects at once, which is ideally where you may want to go, where we integrate everything instead of separating them up. So teaching them all at the same time in a regular schedule, or going with one block and in another block works as well, or a complete integration is another way. And I don't have a preference. I think it really depends on your teaching style, or your confidence level, and your students as well to make that choice.
Awesome. I'm in the middle of typing an answer to something else. Someone was asking about the scientist posters that I shared yesterday. So the links for yesterday's session aren't posted quite yet, but I'm sure they're on their way today because they were sent at the same time as some other sessions that are already up there. But someone had found that those posters of the scientists were also included in one of my other resources that's already up there. So if you have if you're looking for those are coming. And as I say, I think the session from yesterday will be posted soon. I have one more recorded question. It was specifically about the I know and the I can statements. And they were wondering if the I know statements were taken from the knowledge and understanding, and then the I cans taken from the skills and procedures.
That's where it's going to end up being. I'm not too sure if these are something that I fully like doing or not, but they're going to be there for those school jurisdictions that want them, require them. That's exactly what we're going to take the I cans, and you're going to find the verbs are going to be in there, and the I knows are going to be related to the knowledge pieces. I'm tempted to put in I understand in there. I can understand this, but that's not going to happen. But yes, the I know and the I can are going to be related specifically to the knowledge and the skills part.
There's been quite a bit of flurry in the chat too. I don't know if you're having a look now. There was
Maybe I'll open now. You know what? I'm going to stop my presentation. You know what? Let's
and
stop.
I'm going to stop.
Well,
I'll actually stop the recording now too.